drive isn't just about automotive electronics or renewable energy, although we tend to talk a lot about that because they're hot markets, they're emerging markets. And you have a focus in Asia, which we have a good sense of what's going on in North America, an okay sense on what's going on in Europe. But tell us what's going on in Asia and how, particularly how the U.S. Design houses, U.S. vendors can be competitive there.
Absolutely. Yeah, so there's a lot of work. I think we hear kind of two stories sometimes. We hear a lot about how China is investing significantly in coal-fired power plants and boosting their energy productivity that way, production. But we also see a huge amount of investment in renewable energy technologies. Some that are very common to what we have here, such as solar panels, wind turbines. Some that are a lot more specific to kind of the market needs. For instance, in Korea, we're working with a lot of companies that are working on fuel cell systems for energy production inside of houses. And so what they'll do is they'll actually take natural gas, which is already piped to a lot of condos and different places. They'll actually break that down to get the hydrogen out of that. The byproduct, of course, is heat. And so they can take that heat and actually have a water heater now in their apartment and then be able to produce electricity for the condos. So that's an example of a technology that's used very specifically in Korea. I think we'll see a lot of adoption of it in Japan because of different constraints. But to be able to build that system requires a huge amount of embedded intelligence and monitoring capabilities. And being able to monitor a lot of that data that's coming in from those processes, being able to perform analysis on that, and then be able to control pumps and actuators and things like that to make it a very safe product. So if you think about the amount of potential for just different types of malfunctions in that equipment, the safety, the monitoring, and the control has to be extremely tight and proven out. And so that's an example where we can come in and help as a producer of measurement and automation tools and help them be more successful in kind of the designs and the technologies that they're developing.
So I first started engaging with National Instruments probably about 10 years ago. And then, if I recall correctly, there was a lot of medical, there was a lot of industrial, that kind of market application you guys were focused in. Everybody in the industry then sees things like renewable energy pop up as an application, automotive electronics. But in your space, and within a company that is moving so fast and growing quickly, how do you respond? How did you respond over those 10 years to that emerging market? How did you staff up? How did you figure how to sell the right technologies into that market?
I think one of the things that we do as a company is we provide horizontal tools, engineering tools that we really focus on the measurement capabilities, the control capabilities. And so what inevitably happens is wherever there's a lot of innovation, wherever there's a lot of focus from the engineering communities, our tools will be used. And so oftentimes we don't decide to really focus in on the market so much as we're pulled into the areas where there's a lot of investment. As we get pulled into those areas, we then always kind of identify there's probably specific areas that we can adapt our platform and adapt our technologies to kind of complete the overall product so that we can maximize our benefit for those areas. And so as we get pulled into some of these areas, our core platforms will already be able to be used. But as we work with customers and understand them more, we'll try to learn what they're doing and kind of how they would like for our products to be improved and work with them to really kind of bridge that last gap to make our products work great for them.
So in your role, are you the guy who's looking at all sorts of research all day long and then saying, at some point there's a tipping point and going, now we have to shift our gaze a little bit here, or are you that guy, or does that come from on high?
A little bit on high, and a little bit from just working with customers. And so because we serve such a broad audience, it's very hard for our sales force to become absolute experts in every single area. So what we do is we all, I think, become experts in measurements and control technology, but by focusing on different industries, our teams here and our teams in the field can become more familiar with the exact needs and requests of specific areas. And so from that knowledge and from looking at what different customers are asking for, we can say what are the common things and then bring that back and work with our R&D teams, our product marketing teams here to determine how we can best adapt our products moving forward.
One of the things that impressed me years ago here was how products like LabVIEW were starting to be pushed into non-traditional markets, not just engineering, but other places like medicine, like putting LabVIEW in the hands of doctors. How do you evolve that technology with that in mind, without sort of cannibalizing the traditional core value of the technology in core markets?
What we're trying to do is provide an integrated hardware and software platform that can be used for virtually any application that has measurement and control as part of the application. Whether that person is a medical specialist that's working in medical research, or if the person is a mechanical engineer that's working on a control system, we want to have the hardware software platform that can help them solve that application. So at the core is the flexibility to solve anything. So we can stay true to the core of the platform and meet the needs of that medical specialist, that person doing medical research. But the way we can help is we can help them with their application, with our partners, with our systems engineers, with our support. So oftentimes the inspiration for our applications comes from our customers and from what they're trying to accomplish, but the work done to make it happen is done by the customers as well as our partners, and we lend a hand if needed.
I represent the group that's focused on simulation and advanced control, but I have colleagues, some of whom are in the room, that focus on very deep dives in other innovative fields, medical, energy from a monitoring standpoint. We have system engineers that are focused on all sorts of very intense applications that really we focus on those because we've matched up with our customers who are requesting us to focus on those. And so we've been given the opportunity to dive into those areas because of what's been brought to us, because of our broad platform of tools.
What's popping up on your radar that you guys are, in the next 12 months or 24 months, going to have to start to address application-wise?
We're seeing a great deal of innovation in the area of vision. So embedded vision is a trend. I think most everyone has seen the Microsoft Kinect products, which is taking vision and the interaction of people with vision systems to a whole new level and inspiring people to think about applications in a different way. So I don't believe that this is something that we're going to tackle in the next 12 months or 18 months, but with our vision platform, we're being pulled into all kinds of exciting applications with humans interacting with vision systems. And I think over the next decade, that's going to be a very exciting area of growth and innovation, similar to what's going on in the energy market today.
At the application level, is that being driven in North America? Is that innovation coming out of North America or Europe or Asia or someplace I'm not thinking of?
Yeah, most of the innovation that I'm personally involved with, and I'm sure there's innovation all over the world in embedded vision, but a lot of that's happening in North America.
Talk a little bit about your role and what's going on here, because the larger question for us at EE Times and for National Instruments is, how do we get more kids involved in science and technology?
No, that's a great story, and this is part of why I just love the job that I do, is I get to see these things happen all the time in the midst of the media talking about crisis in STEM education and the need for more scientists and engineers. I run into inspiring stories like that all the time, where a particular individual or teacher is creating an environment to really inspire these kids. And I think that's important. I think all of us who are engineers can probably tie back to a time in grade school where a teacher or a parent made a difference or introduced you to something that allowed you to then become an engineer. And on the education side, from National Instruments, I mean, it's a cornerstone of our corporate responsibility. Our company is rooted in education, and we, through volunteerism and philanthropy, do quite a bit in education. But I always like to talk about this idea of shared value, whereby because of our decades of experience in creating these tools to help scientists and engineers to innovate and to be more productive, we have a real unique perspective, as we talked about, this diverse sort of industries and applications our tools are used in. And the way we can best help educators is to take that experience and turn it into something in the classroom to make it real for the kids. Because the kids today are growing up in a point-and-click environment. Nowadays it's tap and swipe. But they have information at their fingertips so quickly that in a traditional classroom environment, both in college level and in secondary and primary schools, we're losing a lot of kids. We're taking their sort of natural inkling to innovate, and we're sort of stifling it. But there are teachers out there, a lot of them, that are seeing that issue and trying to really help the students understand when am I ever going to use this. And that's where we invest in products that will take our tools and we'll create. I've got one in my pocket here. We'll take our expensive data acquisition devices and create a little box like that to make it accessible so that students can actually measure and control and learn about science and math and learn why it is important. And at an earlier age, it's well known that we work with Lego Education on the Lego Mindstorms platform to inspire kids to do through robotics to learn about control and programming through robotics.
To your point, getting kids as early as possible to show them that they can actually make things with their hands, right? That's a really tight feedback loop. And also fail, right? Because failure is learning, is really important. Are you seeing that sort of being broadly embraced either in Texas or on a national level? And is that the way to get more kids involved? In other words, do the Lego Mindstorm thing as early as possible.
Right. If you look in the media, the president just announced, I think, $100 million grants to train teachers to solve this the science and engineering crisis that we potentially have in the U.S. in terms of the number of kids not going into engineering. I think there's a big shortfall in the near future, and so there is more and more engineering curriculum. Traditional science and math teachers wanting to incorporate engineering into their curriculum. So instead of just teaching proportions and ratios through, learning about cross, multiply, and divide, you actually can learn it through a hands-on project. For example, just learning about gear ratios, where the kids can actually see why I need to know. It's more than just doing the procedures to learn the math, but it's actually using it to solve the problems. So yes, I think there is increasingly more and more initiatives in our work with lots of people who develop curriculum, where they are the education experts, but we can provide the technologies to make it more authentic, and we can provide it so that it actually will work in a classroom.
Are you seeing the right skill sets coming to you from colleges these days? Is that an issue?
I tend to see, and I won't name schools, but I tend to see a trend in different schools in terms of the quality in universities, in terms of the quality and the career readiness of those students. I think one of the things that we help foster within the universities is to try to retain students through more hands-on capstone projects, where they work in teams, where they can fail. Because part of innovation is knowing that it's okay to fail and taking those risks, and knowing how to work with others and collaborate. And too much in schools, we tend to traditionally have students work on their own, and hey, there's only one right answer, But there are new methods of teaching that are out there, and it's growing, where you're bringing in the real working environment, putting it into education, so that they're much more prepared when they come into industry.
I think the bigger question, and probably what a lot of what we're doing with LEGO is addressing, is how do you encourage kids to actually follow that path and get into those programs? And so I think from the percentage of applicants that we're getting, it's such a small portion of the people out there. And so how do you get a bigger portion of people into that? And hopefully, I think that's with the project-based learning and engaging earlier on, and with some of the more practical application of some of these concepts, that's where you can address that problem.
This company has had phenomenal growth in its history. Everybody's running 110, 150 miles an hour. How do you, in your respective groups, ensure that you are innovating? And I know that's a big word, but people tend, once they get good at a job, to do it kind of the same way, right? You have to form the same habit, the same thinking patterns, the same biases. How do you change it up? How do you keep it so that new ideas flow in and don't immediately get batted down just because they're new ideas?
So I think that one of the things that keeps innovation alive is questioning. And the minute you stop questioning, I believe you have the potential, you'll obviously stop innovating. So internally, we question a lot. Are we doing the right things? Are we doing the things in the right way? Are we focused on the most important things? And as we question and talk about what we should be doing as an organization to achieve our goals, which we have to understand, then you start to naturally brainstorm on how to make sure these things are happening. And another way to keep the innovation flowing is change. If we're not changing things up, if we're not moving around, if we're not getting new experiences as an organization, whether that's in marketing or sales or engineering, you can have a narrow view. And a narrow view can stunt your growth in the area of innovation, whether it's innovating on the business side or if it's innovating on the design side.
And I'm probably the short timer on the board today. I've been at NI for 5 years. And I think NI does a really good job as a corporate culture of encouraging people to move around within the company and stay sharp and interested in what they're doing. I think that's kind of been something that really stood out about NI coming here out of school. But then in general, I think as intelligent and thoughtful engineers, we're always asking, how can we make something better? We've got this working. Well, what can we do to make it cooler or faster or smarter or control it more effectively, or pushing the envelope always. And not only pushing the envelope of whatever we're working on, but pushing the envelope of our own products, and pushing R&D to produce better products, and pushing marketing to move us toward different segments. I think that just kind of the corporate culture has fostered engineers who are constantly pushing and moving outside of what they're comfortable with.
We here at National Instruments, we celebrate innovation. We award it, not only internally, but externally. We have an annual Graphical System Design Award where we really just celebrate innovation in scientists and engineers. And I think in general, at least in my world of working in education, part of it's not just changing the way we teach in the classroom, but also it's a marketing thing regarding engineers and what we do. And so culturally, I think we need to say that, hey, as a culture, to celebrate and to celebrate engineering and really try to show how it's changing our lives, and really letting the young generation be able to see that, hey, that's a career I want to pursue.
What's the number one challenge you face?
I'll talk about something that I see as a common focus with a lot of the customers I have the opportunity to work with, which is everyone's faced with a huge amount of restraints. And specifically, if you look at a high level, especially in a lot of the emerging markets, but definitely here in Texas, we have a huge amount of energy and water and natural resources thirst that we're going after. And we have huge populations moving from out of poverty and into the middle class. And so how do you satisfy that need that I think everyone in society deserves and should have access to? And it's going to put a huge strain on our resources, and really the way to solve that is through technological innovation, and not just in one area, but really adapting to the specific needs of the local conditions.
So I think to add on to what Joel was saying, the first step is measuring and understanding what's going on. And then the natural inclination then is to try to fix whatever you see as a problem. And so, for the stuff that I work on, for the industries that I'm working with, control and advanced control specifically is the solution to those problems. Being able to take a plant and make it more efficient, take an engine and make it run more smoothly, waste less energy, and a lot of that comes from the control algorithms being used. And so I work with engineers to help them improve their control algorithms, but we also spend a lot of time helping them test their control algorithms. So a lot of the work that we do is in hardware in the loop testing, where we take an actual controller, the ECU that controls the electric motor in your Chevy Volt. We test that against a fake system before we plug it into the first Chevy Volt to make sure that when you step on the gas, it doesn't fry something or blow up the engine or let the smoke out. So a lot of the challenges we see right now and a lot of the innovation we're seeing in the fields that I'm working in are specifically how to better test those systems and make sure that the systems are more reliable before you build the first system. The average car now has millions of lines of code running in it, which is insane to think of that. And one little bug in that line of code can cause a Toyota to drive off the road. So our position in that space is to help our customers better test those, better work out those bugs before they get there. And the technology to do that is changing wildly at this point in time. So we're really kind of pushing the forefront of that.
So I think the thing that keeps me up at night is this issue where design teams are getting smaller and smaller, and they're being asked to create systems that are more and more complex. And understanding how to enable those small design teams to meet their challenges. What are the right products to make to maximize the potential of that team? And then how do we help them learn about the tools that are available for them to help them solve these challenges? Because if they don't take the time to rethink the way the teams are doing things, they're going to try to just run faster. But it's a time to take a step back and rethink the way you're doing things and change the mindset and move away from the way it was done 10 years ago and look at a new innovative approach to solving your application. And that's what we're doing here, is trying to provide those tools to change the way systems are designed, prototyped, and deployed. But let's figure out as well how to get people everywhere excited about this new way of thinking.
So I think the biggest challenge is really trying to think 10, 20 years ahead and trying to predict what our world's going to be like and what technologies are going to be there, and how does that then impact the tools that we create, and how do we as an organization stay nimble. You can see that in the last decade, the changes in our world is accelerating at a vast pace with the cloud, with tablets, and who knows what's next. So that's one big challenge, is to continue to evolve our tools and be nimble to those changes, so that we can continue to reduce the time from that innovative idea to actually implementing it into a real product or real product for the company. And then part of that on the education side is that I believe as we get older, we naturally become less innovative, because our brains get wired of more of what we can't do, and we think about the constraints more than we think about what's possible, and that's just natural. But I think that the challenge is for us to invest in the younger generation, so that we can continue to bring in young talent. Because they come in with a blank sheet of paper, and they're not afraid to fail. They're not they don't know what they can't do, and I think that Here, I've seen lots of examples here in our organizations, which because of that has fostered lots of innovation.
Discrete systems, right? They're really complex. They get more and more complex every couple of years. But at least you can kind of put boundaries around them and test them and understand where the faults are and then bring them to market. But as we grow more and more connected as a culture, the whole Internet of Things, for instance, or the smart grid, there isn't one way to throw your arms around the complexity of that. And so there's always the law of unintended consequences where you're not going to think that your customer's product, did something down here because that's not really your job, right? So as an engineering culture, how are we going to manage that complexity in the next 50 years? Because it's not going to get any simpler.
I think one part of that answer, and that's a great question, is what Ben talked about, is being able to do simulations and being able to test more and more complex systems before you kind of put them all in play and turn them on and kind of hope for the best. And so the more you can simulate, I think the more you can be able to predict what kind of different conditions and build products that meet that. But to your point, if you don't know some of the wild things that might happen, it's going to be pretty hard to put those into the simulation. And I think one area specifically that I'm hearing a lot of utilities talk about is, I think there's no doubt that electric vehicles and hybrid electric vehicles are going to become more and more prominent. And what does that do, and how does that affect utility and a grid when everyone comes home at 7 o'clock at night and plugs their vehicle in? And what are the consequences for that? I think the good answer, or the good news, is there's a lot of people that have that on their radar and are thinking about things. But I think it really comes back to this whole idea of measure it, understand the system, and then be able to adapt. And so what we're seeing a lot of utility companies do is move away from this kind of Christmas lighting aspect of distribution of electricity, where one light goes or one node goes and everything on the other end falls after it. And really, you don't know where that problem was, and how do you isolate it? Well, you just send a crew out, and they're going to keep going and going and going until they find it. And so what we're seeing utility companies doing is invest in a lot of monitoring systems and putting those systems all over their grid, and being able to take really high resolution measurements, and with different kinds of analysis and pattern recognition, be able to isolate where faults are happening, be able to identify trends such as a lot of vehicles being plugged in, and being able to address the problem or isolate the problem a lot sooner than later. And so hopefully, if you can identify these trends happening, you can go out, you can send a crew out, you can fix it, you can stop something, you can ramp up another power generation plant before you have these massive blackouts or catastrophes. And I think that's one piece of it that's going to enable us to be a little bit more nimble in addressing these kind of unforeseen issues that happen with rapid technology advances.
I will sleep much, much better tonight. Thank you for taking time out of your day to do a lot more important things, to share your thoughts. This is really, really cool. And it just kind of reinforces what we hear out on the road every day, which is a huge disconnect between what you see in the newspapers and on television and what engineering companies are actually doing. So it helps us all sleep a lot better. Thank you.
Thanks for having me.
Thank you.
Thank you.